So let's talk about amplitude and intensity. Intensity is equal to the power divided by the area. And what we mean by this is the intensity of radiation that you can detect from a source is equal to the amount of energy per unit time that arrives on a unit area. Or 1 watt per square meter is the intensity of light that gives 1 joule of energy per second to 1 square meter of area. We also have an expression here for intensity, which is proportional to the square of the amplitude. So a wave varying sinusoidally has an amplitude A, and the intensity is proportional to the square of that. Now the difficulty with these two equations is that area we use a capital A, and in amplitude we use a capital A. So you have to be very careful which equation we're using and remember what A equals. Is it area or is it amplitude? Here we've got the two equations written again, where instead of a proportionality I've got equals and a constant of proportionality, K, where K is just there as a constant to turn this expression on the right into an equation. If we have a look at intensity and how it varies with distance away from a source of light. So here's a source of light in the center of this circle. And as we move further away from this source of light, the radiation is shared over an area. It's the surface area of a sphere, which is 4 pi r squared. What that means is that the intensity, which is equal to the power divided by the area, is now equal to the power divided by 4 pi r squared, or intensity varies as an inverse square of the distance to the source, which here is labelled r. So let's have a look at a question then. What is the power of a source needed to cover a rectangle 2 meters by 3 meters with light to an intensity of 100 watts per square meter? Well, our equation is I, the intensity, equals P, the power, divided by A, the area. And we know the area because we've got the length and width of this rectangle. And we know what the intensity is, we're given that. So let's rearrange this equation, P equals IA, and substitute our numbers in. I is 100 watts per square meter, and A is 2 times 3. That gives us 600 watts. A 600 watt source will illuminate a 6 meter squared rectangle with light to an intensity of 100 watts per square meter. Let's look at the other equation in action. Waves of intensity 50 watts per square meter have an amplitude of 10 centimeters. And the amplitude of the wave falls to 4 centimeters. What is the new intensity? Well, here is our equation. Intensity is equal to this constant K multiplied by A squared. And the first thing we need to do is work out what this constant K will equal. So K is going to equal our intensity divided by our amplitude squared. Now when I have an intensity of 50 watts, I have an amplitude of 10 centimeters, and that's squared. So that gives me 50 over 100, or 0.5. As long as we're consistent with the units, it really doesn't matter what we use. The unit for intensity is watts per square meter, but the unit for amplitude is in centimeters here. So essentially our constant of proportionality K is given here in watts per square meter per square centimeter. So now let's use that to find what our new intensity is. Our new intensity is going to equal our constant of proportionality, which is 0.5, multiplied by the square of our amplitude, which is 4 squared. Now 4 squared is 16, and 0.5 times 16 is 8. So our new intensity is 8 watts per square metre.